Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahrin Wiswahimi. I'm from J4EM1104H, and today I will present about a lab for MEM360, which is lab 1 turning. Okay, let's we go to the first page, and this is the first page for the lab. And as we can see here, that we need to define that the process that we need to do for the material, for the product here. And as we can see, we need to reorganize which the process that we need to do first. Okay, for the first one, this number one for turning phase, this is a rough turning phase, and the second one is the finished turning phase. Okay, for the number three, I choose a rough contour, and the number four is finish contour. The reason I use contour because for a material, for a raw material here, we need to make a rough design for us to get a better work after that. So we need to get the rough design first, and then we need to detail it with the finishing contour. So uh, so we will put the number 3 as a rough contour, and the number 4 is a finished contour. Okay, and then for the step 5 and step 6, I choose the rough grooving for the number 5, and the finish grooving for the number 6. And the number 7 is a center drilling, and the number 8 is drilling, and the final one is cut off at the number 9. Okay, now I will talk about one of the process that we need to done to get the final product. I will talk about the about the process number 6, which is a finish grooving process. Okay, finish grooving process need a holder of external grooving tool holder, and we need also insert tungsten carbide for parting or grooving. But for application, boring, bar type, and size, we did not use them because for this process we doesn't have to use these three bottom. Okay, for the part C is a description that for cutting speed, spindle speed, chip load, and the feed. Okay, for cutter material, I will use carbide because uh, the HSS is only used for a drill or milling. So anything that we need to anything that we use a cutting process, we will use carbide as a cutter material. And for the cutting speed is 305 meter per minute, and the workpiece diameter is 22, because this finished product, as we can see in this picture, that we want to get a 22 millimeter diameter for the final product. So after we done with the rough grooving, we will use the diameter of 22 to get the final product. And for machine max, we can choose between 5,000 to 6,000. So I will choose 6,000 to easier my calculation. And the cutting edge, for a cutting edge, except for the drill and milling, we will use just one. Okay, and after we done with the calculation, we get the spindle speed, which is 4,410 rpm. The chip load, we get 0.673 millimeter per revolution, and the feed rate is 2,971 millimeter per minute. Okay, and to find the estimated time, I use the length of cut, which is 14 millimeters, and feed rate, which is 2,971. For the 14 mm is this length, where I make the calculation that 50 minus with 22, we will get 28. But 28 is a diameter, so I divide by 2. 14 divide by 28 divide by 2, I get 14 for each type, for the each place at the top and the bottom. So this is where I got the 14 here. After I do some calculation, 14 divided by 2971, I get 0.005 minute. And the last part is part D, which is I use a 2D graphic sketch. And as you see here, this is the finished grooving illustration. That this part look more detailed than the rough cut, than the rough grooving. I'm sorry. Okay, I think that's all from me. Thank you so much.